Hello engineers, welcome to another video on low-level design. In this video, let's tackle another creational design pattern which is called the builder pattern. I hope you're ready. Let's get started. So let's first start with the intent. So this is the intent behind builder pattern. Separate the construction of a complex object from its representation so that the same construction process can create different representations. So there are two things to note here. First is the complex object. So it means that this pattern applies to complex objects. If it is a simple object creation, do not try to use this pattern. It will unnecessarily complicate your code. But if it's a complex object and there can be multiple representations of the same object, then we can use the pattern called builder pattern. So the construction process is the same, but each construction will give us a different representation. So in this kind of situation, we can consider using the builder pattern, right? So let's look at some example use cases. So first example is the email builder. So if you think of an email as an object, there are bunch of things, right? There is a to field, there is a CC field, there is a BCC field, and then there is the subject, and then there is the body, and then there are the attachments. And there are some mandatory fields in this, and there are some optional fields in this. For example, the to address is mandatory and the subject may be mandatory, but the other fields need not be filled, so they are optional, right? And every email object that we construct may or may not use these fields. So in this kind of a situation, we can consider using the builder pattern. And we also can think of the same in the URL builder as well. So if you have a look at the URL, right, it can have the protocol, the host name or the IP address, and then we have the optional port, and then we have the physical path to the resource on that server, right? And sometimes the path can be long, sometimes it can be short, sometimes there can be a port, there need not be a port, it can be HTTP or HTTPS or WebSocket, WSS or anything like that, right? So this type of object creation can also benefit from using the builder pattern. And then we have the document builder. For example, if you have ever seen a document like a PDF or a Word document, there is a header, there is the main body, and then there is the footer and so on, right? And sometimes there need not be a header, sometimes there need not be a footer. So there are some optional elements and there are some mandatory elements. So in this kind of situation also, we can make use of the builder pattern. And another example is the machine learning artificial neural network layers. So if you have ever seen a diagram showing the artificial neural network, you know that there is an input layer on one side and then there are these hidden layers on the other side. And finally, there is the output layer, right? So group of numbers go in, do some number crunching, and then come out with some output, right? Within these hidden layers, there can be multiple configurations possible. So there can be so many dense layers, there can be a dropout layer, there can be a normalization layer, and there can be a convolution layer, and there can be many such combinations like this. And every artificial neural network is different depending on the use case and on the output needs, right? So in this kind of situation as well, we can make use of the builder pattern. Now let's see how this builder pattern is actually implemented. Let's go to our UML diagrams now. So in the design patterns folder, I've made a creational folder and I've added the builder file. Now let's look at the class diagram for the builder pattern. Okay, so this is the class diagram. Let's see. So on top, you can see that there is a builder interface, and this interface is being implemented by some other concrete builder, right? And if you look at the properties, we have a concrete product here, and there are two methods. First method is build part. There can be multiple such methods, and then we have the get result method, which will return the product from the inside, right? So we have a builder interface which holds the product, and then we have the build part and get result, which will have their own purpose. So build part is used to actually build pieces of the product, and then get result is used to return the product. So these are the two publicly exposed methods from this interface, and whoever is implementing this interface will have to implement these methods, right? For example, if I'm building a URL builder, the product is the URL, and build part will be multiple. For example, there can be a method for adding the host name, there can be a method for adding the port, there can be a method for adding the protocol, and so on. And finally, we use the get result method to get the product out, right? And this is the concrete product that we are building. So this is the final document or the URL or the artificial neural network or whatever it can be, right? And on the left side, we have the director. So this is a totally optional thing. If we want to delegate the construction of the product, we can make use of director. So we will try to see examples of using a director and not using a director as well in our code. But the idea behind the director is to kind of reuse similar type of patterns. For example, if I am building a document generator, I can have 2 3 methods here. First method can be construct a PDF, second method can be construct a Word document, and so on. So this takes care of constructing the individual pieces and returning it. Okay. So this is again an optional thing, but it is part of the pattern for us to use. Okay. Now let's look at the sequence diagram. So this is how the sequence of our events will go like. So we have a client on the left side, and client will call upon the concrete builder class to make a new instance of the builder class. And when we do that, we have a new base product created and it is stored inside the builder, like we saw this here, right? So we have a base product which is maybe empty or is in a initial state, but it is part of the builder. And now that builder instance is returned back to the client. Now the client can use this builder instance and pass it to the director and say, director, please construct my product. And the director will call upon the concrete builder for building the different parts, build part A, build part B, and so on. There can be many parts like this. And for each call, there will be some addition to the base product. For example, if I'm building a URL, this can be add hostname, and hostname will be added to my main URL. And this can be add port, and port will be added to the base product, right? So the construction process is taken care by the director. And then once we have the construction finished, we can use the get result method from the builder and get the final completed product, right? So this is the sequence. Again, if we don't want to use the director, we can directly make use of concrete builder and call upon the build methods as part of the concrete builder and get our final product as well, right? So it's a little bit flexible in that aspect. Okay. So let's see an implementation. We're going to code this one. We're going to build a document builder. So this is our builder, doc builder, and we have the final product as document. Okay. And there are multiple parts to it. We have a title, we have a header, and we have a footer as the parts to this document. And whoever is implementing this interface obviously will have to implement these methods. Okay. And we have a director who will take care of the construction. And finally, we will get a document with a title, header, and footer. Okay. And this document also has setters and getters for the final use after the construction of the product. Okay. So this is a typical implementation of a builder pattern. So let's try to see all this in code. So I'm in VS Code now. There is a new folder called builder and we have builder.cpp. So let's try to understand how this pattern is implemented. So going back to the diagram, let's see the final product, what we need. We need a document class that will have title, header, and footer as properties, and then we have some setters and getters. So that is this piece. So this is the final product that we are aiming to build, right? We have title, header, and footer, and then we have setters and getters, right? And now we have the document builder. Document builder will hold the document, okay? And since this is an abstract class or an interface, there will be virtual methods in this. Set title, set header, set footer, and there is another virtual method called get result, right? So this is the document builder abstract class, or we can call it as an interface, right? Now let's see two concrete builders. First is a PDF builder and second is a DOCX builder. So the PDF builder is implementing the document builder, which means we have to implement all these abstract methods. So that's what we are doing here. So for set title, we are passing in a hard-coded value. Again, this can be hard-coded, this can be taken from the user or through some other mechanism. It's up to you. But just for simplicity, I'm just passing a title as PDF title to set the title. And then we have set header to set the PDF header. And then we have set footer to set the PDF footer, right? And if you notice this, every time we use one of the build parts, we are returning this. And this is one of the key aspect of the builder pattern. Because we are returning the same object again and again, we can make use of something called method chaining, which will give us more readability and more flexibility in terms of how we want to construct the product. Okay, let's have a look at this usage down the line. Now let's look at the DOCX builder. DOCX builder is very similar to the PDF builder. It has a title, header, and footer. And again, the rest of the implementation is pretty similar. We have a set title, set header, and set footer because we have abstract methods that we need to implement here. And also the actual product is protected, which means they're automatically passed on from the parent class to the child classes. So that document is already available within the class. That's why we are able to make use of the set title, set header, set footer of the actual document, right? So now, so far we have completed this piece. We know the shape of the product, and now we know the shape of the builder and two concrete implementations. Now let's look at the director piece. So director is exposing one method called construct, and it is taking in a builder object, right? And this builder object can be any one of these, the PDF builder or a DOCX builder, right? And builder is calling upon methods, set title, set header, set footer, right? So here you can see the method chaining. We can add or remove any type of configuration here. For example, if this was a URL builder, you would have builder.add hostname, builder.add port, builder.add final resource path, and so on, right? And there can be multiple such methods like this. Here I have used one construct. You can add construct PDF, you can add construct docx, you can add construct Excel file, and so on. There can be multiple variants, and inside that there need not be a header, there need not be a footer. All these can be optional. And director can take care of enforcing rules. If I want to enforce that title is mandatory, then I must set a title. And if the header and footer are optional, I can take in input from a user to ask, do you want to set a header? Do you want to set a footer? And so on. So all kinds of flexibility can be possible here. So this is the director class who is responsible for actually constructing the product, right? Now let's see the actual implementation. So first we have the director, and then we have the PDF builder. We have these two new objects, and we are passing in the PDF builder object to the director and calling upon the construct method. So director is responsible for constructing the object. So once that is done, we have the PDF builder dot get result, which will return our actual product. We have the final PDF, and we can use that final PDF to do any kind of operations. The get title, get footer, get header, since these are the getter method from the actual product, right? So this was an example of using a director. But like I said, director is an optional thing. So we can directly make use of the builder as well. So if I am creating a docx builder, I can directly call upon the docx set title, docx set header, and I can get the result from docx builder as well. And I can use the final doc to call upon get title, get header, get footer, and so on, right? Again, here you can see that I have used the docx builder to set the title and header, but I have not called upon the set footer. So ideally this would have returned nothing or undefined, right? So in this way, we can make use of the methods inside the builder to create any type of representation of a complex object, right? So you might be getting the question, if you already have setters and getters for the document itself, why do we need to take the headache of adding a builder and adding a director, and then make the director use the builder, and then use the builder to construct the product and return the same document, right? Again, the benefit of this pattern is to build complex objects. That is where you will see the real benefit of using this pattern. So if there are so many variants of this that can be possible, there can be a pretty lengthy document, and every time we have to manage in the main class, right? Like this. And this can be cumbersome if your code base is very huge. And the director also, I have shown a simple implementation. We can make use of the director to build different patterns. For example, if you're building an artificial neural network and you want to do an image classifier, so you can use a method called construct image classifier, and that director will already know what are the layers that are required for building an image classifier. And there can be other methods for different types of configurations as well. So you can kind of simplify the object creation. You can make use of the director to build reusable patterns and so on, right? So only when the object is complex enough to consider a builder pattern, that is when the benefits come out of using this pattern, right? So let's run this code and see. Yeah, as we can see here, we have the PDF title, header and footer that we have set in the PDF builder. And then we have the document title, document header that we have set up in the DOCX builder, right? And as you can see, there is no footer printed because we didn't call upon the footer method while building our final docx file, right? So that way we can make use of different configurations. So that is the whole implementation of the builder pattern. Now let's look at some pros and cons. So far we have seen the intent, the example use cases, the diagrams, UML diagrams for the builder pattern, and we have also seen the code. Now let's talk about some trade-offs. So these are some of the strengths of the builder pattern. The first is separation of concerns. This is following the single responsibility principle because the director is taking care of construction, the builder is taking care of giving all the methods and parts that are required to construct the object but not enforcing them, and then the document itself can do its own thing after it's created, right? And then we get flexibility in complex object creation. This is one of the main benefits of using this pattern. We can create different representations of the same object by following the same construction process again and again, right? So that is the main strength of this. And obviously this is very extensible because the type of builders that we want to create is up to us. There is a common interface and we can just keep on adding builders, right? So these are some of the main strengths. And then let's look at some weaknesses. So like I said, this pattern only benefits if you are dealing with a complex object. But if it's a simple object with just a few methods and many of them are mandatory, no need to use this pattern, right? It can overcomplicate for simple objects. And learning curve is slightly high because there are multiple pieces involved here, and it can take a little while to understand why this pattern is useful and how it is implemented, right? And the last one is immutability, right? So we want to use this pattern when we want to create concrete products that are not likely to change after they're created. For example, in the builder classes, there can be many validations that will naturally accept some inputs and reject some other inputs. And there can be constant methods, constant properties that should not change after the object is created. And there can be additional complexity in dealing with such validations and constant members, right? So in that case, there can be immutability challenges because once a product is created, it is a concrete one that likely should not change, right? So that is something to keep in mind. So we need to make our pattern strong enough so that it can support different combinations without having to affect the integrity of why that builder is there in the first place, right? So that is something to keep in mind. So these are some of the trade-offs of using this pattern. So if you have come across any other trade-off, definitely put them in the comment below so that I can learn and everybody can learn and share, right? So that's all I had for this video, guys. Thank you so much for watching. I will see you in the next one. Meanwhile, if you haven't subscribed already, don't forget to subscribe and share it with your friends. Do leave a like if you found this video helpful. Thank you so much for watching. I will see you in the next one. Cheers.